Hi, everybody. It's Professor Mitchell. We're continuing with Chapter 7 today, looking at Section 7.3, which is adding and subtracting rational expressions with common denominators and least common denominator. So what this section does is it gets us ready for the next section where we're going to be adding and subtracting rational expressions with unlike denominators. So the three objectives in this section are to add and subtract rational expressions with the same denominator, find the least common denominator of a list of rational expressions, and then finally write a rational expression as an equivalent expression whose denominator is given. And just like with a lot of other things, that'll make more sense when we actually get to it. Same SLO that we've been working on throughout this chapter. So let's get to it. All right, so you know me, I like to start with simpler, happier times. So when you go to add the fractions 7/12 plus 1/12, how do you do that? So let's switch over to the tablet real quick. Oh, give me one sec. Okay, so I've had to find a new way to share my tablet. The old way stopped working the other day. So this is a little clunkier. Anyway, it's working. All right, so 7/12 plus 1/12. In general, addition and subtraction of fractions, which includes rational expressions, can be a little bit more of a pain than multiplying and dividing because you need common denominators. If you have a common denominator, it's really easy. All you do is just add or subtract your numerators, right? So 7/12 plus 1/12 is going to be 8/12. And then the only thing that makes this problem even a little interesting is that you have to simplify your answer. So 8 is 2 times 4. Oh, you know what? No, that's right. Okay. And 12 is 3 times 4. You get rid of the 4s. And the simplified answer is 2/3. Okay, so that's the way it's going to work when you throw x's and y's into the mix. So the rule is just keep the denominator and add or subtract your numerators. So here are the three examples. So let's go back to the tablet and we will take care of these. Okay, so first example, x plus 1 over 7 plus 6 over 7. So this really isn't any harder than 7/12 plus 1/12. Just keep your denominator, which is 7, and add your numerators. I'm going to show an extra step here that you really don't have to show. Of course, x plus 1 and then add 6 just comes out to x plus 7. Now here's my question for you. Can I simplify this x plus 7 over 7 by crossing out the 7s and simplifying it to x plus 1? Okay, so hopefully you're yelling no, because no, you can't. The 7 on top is a term. Remember, you can only cancel common factors. So if it was x times 7 over 7, then I could do that. But because it's x plus 7 over 7, that is already in simplest form. All right, so next example, 8y over y minus 2, subtract 16 over y minus 2. So once again, keep that common denominator and this time subtract your numerators. Okay, and then always ask yourself, can you simplify your answer? And in this case, you can, right? Because you can factor an 8 out of the numerator, which leaves you y minus 2. And hey, look, y minus 2 is the same factor I have downstairs. So now I get rid of the y minus 2s And that simplifies to 8 over 1, which is just 8. All right, last example. Come on, there we go. All right, 6x squared over 2x minus 5, subtract 25 plus 2x squared over 2x minus 5. Now, there's one slightly tricky thing about this problem, and it's not this part. Keep the 2x minus 5. All right, what you're doing in the numerator is you're taking 6x squared and then subtracting 25 plus 2x squared. So in order to subtract the whole 25 plus 2x squared, you have to put that 25 plus 2x squared in parentheses. All right, so don't forget to do that. And then you will distribute this minus sign, which will give you 6x squared minus 25 minus 2x squared over 2x minus 5. Now you can combine your like terms. 6x squared minus 2x squared is 4x squared minus 25 over 2x minus 5. So now, can I simplify that answer? Yes, I can, because 4x squared minus 25, what do we call that kind of expression? That is called a difference of two squares, right? And that factors into 2x minus 5 times 2x plus 5. And when you put that over 2x minus 5, you can get rid of the 2x minus 5s, and the final answer is 2x plus 5. All right. So that's adding and subtracting with like denominators. Pretty simple. All right, let's go back to presentation. All right, so next, finding the LCD of a list of rational expressions. So hopefully you know how to do this with regular old fractions. We're going to go over it. Okay, so let me just show you the steps. It's kind of similar to how I showed you how to find greatest common factor, with just a couple of little differences. So first, I'm going to prime factor the numbers. All right, that's exactly the same as what we did with GCF. Write the prime factorizations in columns, which is the same exact thing we did with the GCF. Okay, now here come the different parts. When we were finding GCF, I told you to circle the smallest power in each complete column. This time we're going to circle the largest power in every column, including the ones that are not complete. And then when you multiply those circled powers together, that's your LCD. All right, so let's have a look at that. Okay, so step one, we're going to prime factor our denominators, starting with 24. All right, that is 8 times 3. 3 is prime, so I'll circle that. 8 I can write as 4 times 2. And then 4 I can write as 2 times 2. All right, and then 45. I'll write that as 9 times 5. 5 is prime. Sorry, my screen on my tablet lags a little bit when I'm doing it this new way. All right, and then 9 is 3 times 3. Okay, so when I go to write those in columns, I'm going to write the 24 as 2 to the 3rd times 3. So I have a 2 column and a 3 column. And then the 45, I'm going to write as 3 squared. Notice I skipped the space under the 2 because 45 does not have any factors of 2. So we have 3 squared times 5. So I have a 2 column, a 3 column, and a 5 column. All right, and now I need to, just waiting for the screen to catch up here. Now I need to circle the largest power in each column. Okay, it's starting to catch up. I put a dotted line between the 3 and the 5 like 20 seconds ago. For some reason, it's not there yet. Okay, there it is. All right. So in the 2 column, the only one who showed up is 2 to the 3rd, so that's automatically the largest. If I was doing GCF, I would have skipped this column because it's not complete. All right. However, I have circled 2 to the 3rd. I'm just waiting for it to show on my screen. All right, well, let's continue to the 3 column. So in the 3 column, it's 3 versus 3 squared. The larger, there it is. The larger power is 3 squared. And in the 5 column, the only thing that showed up is the 5. So that automatically gets circled. And so my LCD is the product of all those circled factors. It's 2 to the 3rd times 3 squared times 5, which of course is 8 times 9 times 5. And I'm pretty sure that comes out to 360. All right, there is another way to find LCD, and that's just to count by 24s and count by 45s until you hit the same number. I wouldn't recommend doing it that way with 24 and 45. That would probably take you a really long time. All right, and also people tend to make mistakes when they try to count by numbers like 24 and 45. All right. At the bottom, notice what I have typed there. This is a little mantra that I made up a few years ago that hopefully is helpful to find LCD. So to find LCD, it's just saying every factor you ever see to the largest power you ever see it. In other words, circle every factor you ever see to the largest power you ever see it, and include those in your LCD. All right, let's go back, see what our real examples are. Okay, here they are. We're going to find the LCD for each of these lists of expressions. There they are right there. I believe that's all of them. Yes, it is. All right, so let me get the tablet ready and then we'll go back. Okay, so we have 1 over 6y and 3x over 4y plus 12. Remember, the directions were to find the LCD for this list of expressions. All right, so the first thing I'm going to do is factor those denominators. In this kind of problem where we're just finding the LCD, the numerators have absolutely nothing to do with it. You can ignore those numerators. All right, well, 6y, we don't really think about factoring 6y. It's just 6y. Although, you know what I think I will do? Because we're also dealing with prime factors, maybe I will write that as 2 times 3 times y. And then the 4y plus 12, that there is some factoring to do. I can pull out a 4. Let's do this. So up here, I'm going to write that 4y plus 12 is 4 times y plus 3. And then I'm going to write that 4 as 2 to the 2nd. I don't have a factor 3, so I'm going to skip that column. And I don't have a factor y. This might take a little getting used to, but I have a factor y in the first denominator. In the second denominator, I have a y plus 3. Those are completely separate factors. So that gets its own column. So there are a total of 4 columns for this problem. And in most of them, only one person showed up. So in the 2 column, 2 to the 2nd beats 2. And then in the other columns, nobody else showed up. So we're going to include a 3, a y, and a y plus 3. So the LCD for this list of expressions would be 2 to the second times 3 times y plus 3. And I would write that answer by multiplying together the 2 to the second times 3. So that comes out to 12. I would write it as 12y times y plus 3. Now you might be wondering, that answer will show up in a second, hopefully. There it is. You might be wondering, should I distribute that 12y? And the answer is it doesn't really matter. I would recommend just leaving it like that because when we get to the next section, you'll find that it's actually simpler to leave it like that. It makes the rest of the problem easier. Okay. All right, so I would just leave it as 12y times y plus 3. All right, next example. We have 19x plus 5 over 4x minus 12 and 3 over 2x squared minus 12x plus 18. All right, so let's do this. 4x minus 12 is just factoring out of 4, so that would be 4 times x minus 3. And then 2x squared minus 12x plus 18, you would start by factoring out a 2, which would leave you x squared minus 6x squared minus 6x plus 9. And then that trinomial can be factored. Numbers that add up to -6 and multiply to 9 are just a pair of -3s, right? So it would be x minus 3, x minus 3. I'm going to write that as x minus 3 squared. All right, so when I go to put those in columns, let's write this one as 2 squared times x minus 3. And then the other one, I like it just the way it is. I'm going to write that one as 2 times x minus 3 squared. So I have 2 columns. Everybody showed up in both columns. In the first column, 2 to the second beats 2. And in the second column, x minus 3 squared beats x minus 3. So the LCD for this list of expressions would be 2 squared, which is 4, times x minus 3 squared. And again, I would recommend leaving it just like that. All right, last example for finding the LCD. As usual, whenever you want to try one of these ahead of me, I always encourage that. Just pause the video, try it, and then come back and compare notes. Okay. All right, so this one I think I'll just skip to writing my factors in columns. Let's see. Change this to black. X squared plus 4x plus 3. Numbers that add up to 4 and multiply to 3 are 1 and 3. So we'll do x plus 1, x plus 3. And then x squared plus 10x plus 21. Numbers that add up to 10 and multiply to 21 are 3 and 7. So be sure to put the x plus 3 under the other x plus 3. They go in the same column. X plus 7, though, gets a new column. We've never seen an x plus 7 before. All right, so I have 3 columns here. In the first column, nobody else showed up. In the second column, it's a tie, x plus 3, x plus 3. Just pick either one. And in the last column, nobody else showed up. So for this problem, the LCD is, and this is exactly how I would write it, x plus 1 times x plus 3 times x plus 7. Okay. I say that's exactly how I would write it. Of course, those factors can go in any order. So if you wrote it as x plus 7 times x plus 3 times x plus 1, that's perfectly okay. All right, so I think I just have one more kind of problem to show you. And again, we're going to be using all of these in the next section. And that is writing a rational expression as an equivalent expression with a given denominator. I've always wished there was a catchier name for this. All this is, you know what, let me show you this one, and then I'll just show you the examples, and that way I can switch back to the tablet and just stay there. All right, if I ask you to rewrite 3/8 as an equivalent fraction with denominator 40, I bet you would know how to do that. All right, we're going to go over it, but I bet you know how to do that. And that's all this is. All right, except of course we're going to be throwing X's and Y's into the mix. Whoops. Okay, so it looks like I have two examples, two real examples, after we do the easy one. So one last time, going back to the tablet. Okay, so to rewrite 3/8 as an equivalent fraction with denominator 40, all you do is, I like to set it up like this. Okay. You think to yourself, 8 times what equals 40? And the answer, of course, is 5. All right, and then if I'm going to put a 5 there, I have to put a 5 there. All right, 5 over 5 is equal to 1. So if I multiply 3/8 by 1, it does not change the value of the fraction. That's very important. And so the new fraction, the equivalent fraction with denominator 40 would be 15 over 40. 3 times 5 is 15. All right, and that's what you do. So let's see, it's almost just as easy when you throw X's and Y's into the mix. So in this example, we have 3 over 9y to the 5th times mystery fraction equals 72y to the 9th. Okay, so this time the question is 9y to the 5th times what equals 72y to the 9th? So let's start with the easy part. 9 times what equals 72? That would be an 8. All right, and then y to the 5th times what equals y to the 9th? That would be y to the 4th, wouldn't it? Because 5 plus 4 equals 9. That's the product rule for exponents. And of course, if I'm going to multiply the bottom by 8y to the 4th, I have to multiply the top by 8y to the 4th. So that would make my new numerator 3 times 8y to the 4th, which is 24y to the 4th. All right, whoops. Okay, I've got notifications showing up on my screen. All right, last example. 5x over x cubed plus 2x squared minus 3x is equal to what over x times x minus 1 times x minus 5 times x plus 3? All right. Okay, so for this one, we're going to have to factor the x cubed plus 2x squared minus 3x. So the first thing I notice about that is that it has a common factor, x. I tend to be a little picky about my colors. In general, I like to do the problem in black and then do the answer in red. And sometimes I use other colors if I want to highlight certain things. When you pull out the x, you get x squared plus 2x minus 3. And then that's that easy kind of trinomial. Numbers that add up to 2 and multiply to -3 would be -1 and +3. So if you write the original problem like this, 5x over x, x minus 1, x plus 3, and then say times mystery equals, try to squeeze this in here, x minus 1, x minus 5, x plus 3. Okay. I see the only factor that's missing, I see an x here, I see an x here. I see an x minus 1 here, I see 1 here. I see an x plus 3 there, I see 1 there. The only thing I don't see is the x minus 5. So that's the one we have to bring in. And of course, if you multiply the bottom by x minus 5, you got to multiply the top by x minus 5. And that would give me a new improved numerator of 5x times x minus 5. And we'll just go ahead and leave that like that. I think when you go to do these homework problems, I think in this case, your online homework program does distribute the 5x. It really doesn't matter. We're kind of doing this step of the problem a little out of context right now. When we work this into the kind of problem we're going to do in the next section, you'll see where we have to distribute the 5x, okay? In the meantime, I think that is perfectly fine. And that's going to do it for section 7.3. So we'll see you next time.